What is it?
Come.
Oh, shut up.
Hello. Should be fine. What?
Let me get the save point first off. I don't know. I haven't played the fucking game.
Hello.
Actually, is there a save point back here? You don't get to save your you don't get to save your progress. Yeah. What? No, there's just not auto save. No.
How is my mouse double clicking already? Not normal, man. I just bought this mouse like not until 2 years, bro. No, it's not until, bro. It's not even like 2 years. Bro.
Do you play geometry with your mouse?
No,
Okay.
but Justin did, motherfucker, man. Oh my god.
I mean, he didn't play. How long did he play? He didn't play like 20 hours with it, right? Well, shut your
No, he did. Yeah, but no, but he played like for 2 hours straight at my house.
2 hours. Bro, I slammed my mouse and it like took like 20 hours for my mouse to be like that.
Is it Logitech or what do
Yeah,
you
no
call it?
shit, it's Logitech.
Yeah,
That's why I told Justin not to spam it, bro.
Where's the save point, man? Seems like a good place to put a save point, don't you think, game? Okay.
What's your guys' favorite weapon? No. Why is this leveling up? What the hell?
Seems like a cutscene. Oh god. Got it. Ralph, are you there? I found a safe house. I found a safe point. Alright. Let's go.
Pussy.
Okay. Explain one advantage of this is okay. What? It's more. It destroys that environment. Fossil fuel requires mining and mining. What? Sorry. What? What is? I think so.
Bro,
From living matter. So you use living matter. It doesn't this as long as it's from living matter. Combustion of biofuel derived from plants will have a lower greenhouse impact. Yeah, same thing. Well, whatever. Biodegradable, renewable, fossil fuel, sustainable. Sure. Yeah. Why is that in chemistry? Okay. Nitric acid can be produced industrially with a process shown. Oh my god, this reminds this Greg Tech. This reminds me of Greg Tech. Although they don't use ammonia in Greg Tech, they use Greg acid. Okay, I don't think that matters. I think we should just focus on the question. A mixture of NO2 and N2O2 enters reactor 3. No. Where only NO is consumed by reaction with water. So this only NO is consumed. NO2 is consumed. Oh, okay, sure. Explain with Le Chatelier's principle what happens to the M2O4. What is the Chatelier? I don't remember. But like what?
That's like the pressure, temperature.
Yeah, I know. What does it have to do with this? I guess the pressure lowers. This. Yeah, this is it in reactor 3. A mixture of NO2. I'm gonna zoom out a bit. A mixture of NO2 and N2O4 enters reactor, where only NO gets reacted to become NO and HNO3. What happens to this? Because of the concentration lowers, I'm just gonna. I think the pressure increases. The pressure decreases, and then Hmm. Oh, wait a second. This is a reversible reaction. So N2O4 can turn into 2NO. So if the concentration of this lowers because it gets reacted to turn into these things, this should the equilibrium will shift to the right, meaning this will be more of this will be turned into this. More N2O4 will be turned to 2NO. So so we have N2O4s. Let's say we have 100, and we have 100. Uh, NO2, right? Let's say this is equilibrium. If this gets reduced, this will turn into because if when concentration decreases, it will shift the equilibrium will shift. So this will turn. It will no the it will the N2O4 and it will turn to 2NO2. I don't think the pressure matters. So I think eventually all the N2O4 will turn into 2NO2s and it gets reacted into these products. Let's check the answer.
Good.
Exists in equilibrium system as reactor 2. NO2 is a reactant in reactor 3 and consumed by reaction in reactor 3, causing a disturbance in the equilibrium system. According to Le Chatelier's principle, the position of the equilibrium will shift to counter the depletion, causing the decomposition of the and depletion of N2O4. Ultimately, all of the N2O4 will decompose into NO2. I am correct. If it's running long enough, yeah. It's here. Yeah. This is the this is the what's it called? N2H2 box. This is the 2NO2 box. This is just NO2 box, I guess. There's the this NO2 box. This oh fuck me. And this is the you put in water. I guess let me put like that. This turns into NO and H and O. Let's say there's like 50 here. There's 100. This N2O2 will only convert and decompose into NO2 if this is less than 100. So if let's say this is used, so there's some amount of the things here. This will decompose, and it will create more NO2, and it will eventually become 0. This also becomes 0, and it will become these side products. Yep. Explain 2 improvements that can be used. Okay, how to improve the design of the system can be made to the design of the process shown. Fucking no. Wait a second. Can you just put water here to improve? I mean, and the heat. Can you reuse the heat here? I mean, that's all I can think of. You reuse the water and heat created by the separator water and coolers. No, I don't know. Separator water can be heat can be yeah, okay. A recycling of just use logic. Wow, no, you look at this, you see water in, water out, you connect it. I don't fucking know. I'm just guessing. Yeah, you need to like take care of your resources so you don't waste anything. Yes, trust us. This is why you play Greg Tech. A student has been asked to produce 185 milliliters of ethanol. Oh god. By fermenting glucose use. Okay, given the density, calculate the volume. Oh god, I don't remember this formula. What? Wait. You wanna volume? Volume. Grams. Wait. Um. This is the.
I love.
We need the volume. We need the volume, right? So we have this. This is just stoichiometry, right? Or am I high? Oh wait, the student has been milliliters of ethanol. What's the density of all? Oh wait, okay. This can be find the grams. This can be used to find the moles, and then we can use the mole ratio to find the carbon dioxide, and then we can use the standard gas. Okay, something like. Okay, basically, what we want to find is the volume of carbon dioxide gas, right? So we reverse engineer. Yes, we try to find this. This is the end goal. To try to find this, we need to find the moles of this. You can find using the mole of this. Mole ratio. For example, let's say electrolysis of H2O turns it into H2O to H2 and O2, right? If we have 1 mole of if we have 1 mole of this is going to generate 1 mole of this and 2 moles of this. Yeah, so we can use this. Yeah, it's just because of the formula. The mole of this is the same, but this is because there's you multiply this by 2. What, sorry? This doesn't matter. This doesn't matter. So 1. What? What do you mean? What, sorry? Because that's not. We don't care about that. That's not what they're trying to find. No, this does not matter. I don't know. This doesn't matter. It doesn't matter. We don't understand. This doesn't matter. Ralph, the ratio of this 1, it's 1 to 2 to 2. This is the ratio. Because 1 creates 2 of this, right? This doesn't matter because we're not trying to find this. Yeah. Yeah. So we find this. We're trying to find the moles of this because to use the to find the mole ratio, we have to find the mole, of course, right? I got a mole over here, but it needs a gram. To cancel the gram, we have a gram over here, but it is milliliters, so we find you use the milliliters.
Yo, what? Oh, fuck.
So-
Eating raw, yeah.
We wanna
Yeah.
we need to find mole. Find mole, right? We need to find, but we have grams mole minus 1. So we can use this to find the mole, but we need grams. So we use grams milliliter minus 1 to find this, but we need milliliters, and we have milliliters over here, so we use milliliters to find this. It's the unit cancellation we were engineering, the thing. Because I don't know the fucking formulas. I don't remember the formulas. I'm not gonna remember them. Just do it. We never got taught it in translation, to be honest. We just got taught the formulas memorized. What, sorry? So first, we want this milliliters to find the grams. Milliliters. This is -1. So what do we do? Multiply or no? This is 1. This is -1. If we multiply, it's 1 plus -1, which is 0. We wanna eliminate milliliters, Ralph. 185 milliliters multiplied by 0.789 grams milliliters minus 1. We get to cancel these two, so we get grams, which is it's useful for yourself. So we get 1/4. I always write units, always, because I don't like to get confused. Yeah, I know. But if you want to do unit cancellation, obviously you need to write the units, right? So grams. We have grams here, and we have grams mole -1. So do we multiply or divide? Correct. We want to get mole plus 1, so we put this at the bottom denominator, so it becomes mole and not mole minus 1. So on units, yeah, it is. This -1, but it's 1 over x -1 equals just x power of 1. That's why we put it in the bottom. We cancel this and we get them all. 0.08. 3. Yeah, that's the point of it. All right then. What's that? What order? -1. Okay, so let's say if we have 146 grams and for, you mean like this, right? Or something? Or do you mean this? Which one do you mean? This and this is the same. The first one. So the first one, because grams is positive and is negative here, we multiply it instead. So we are trying to find mole. That's the point. Yeah, that'd be right. But the unit is not this, because what the fuck is this? Is this? So, oh, sorry. If it's positive and positive, you divide like this. This is grams positive, grams positive. Yes, and for divide specifically, if the one you want to find is negative, you put it at the bottom, so it becomes positive, because you want to put on positive, not this, right? If it's just mole, you put it at the top. Let's say we have grams and grams mole minus 1, right? We want to make the small not minus 1, so you put on the bottom. But if it's small plus 1 like this, so you put it on the top, so it becomes small. Yeah. Sometimes you want to find like seconds, -1, which is like, is it frequency? then sure. But like that's really weird. Who the fuck finds this? What, sorry? Seconds minus one is frequency, Ralph. One over seconds is frequency, right? Yeah, it's frequency. Ralph. Yeah, no, it's logic, Ralph. One second. Let's say 3 seconds is one. This is zero. This is where you start. It's 1, 2, 3 seconds, right? But when it's 1/3 seconds, but sorry, it's one. If it's three frequency, it's what is how many times it is in 1 second. So it's 3 times per second. It's more like this. This is frequency. So it's 1/3. 1/3. This is 1/3 seconds. Statistics. Is this gas? The gas. Ooh, wait a second. Wait a second. Volume. Volume. Let me save this. Ideal gas equation. Fuck. You need to remember this equation. You cannot unit cancel this because there's a lot of memorization. EVEDANTE. Yeah, I don't memorize this. The units for this. You probably do, but like I don't know. R. Oh yeah, R. This shit. What, sorry? I'm thinking because I forgot the formula. Okay, right. So what? Well, this is pressure. The pressure is P equals 100 kilopascals, which is yeah, and then do we need this to be kilopascals or pascals? Well, let's put it here first. We want to find the volume. Volume is what we want to find. N is the number of moles. 3.17. R is that that number is in the calculator. T is 130. Just put in this formula, no? V equals to 3.17 multiplied by 8.31. This is. Wait a second. Temperature, I mean, it's 310 divided by the pressure, which is 100. Let me put this in the calculator. 3.17 multiplied by 8, 1 times 310, or divided by 100. 81.7. For gas, you don't have to do mole ratio, I think, for this using this formula. Yeah, I would say it's this. I would say it's this. Use 6.7 or whatever. Ralph, how much significant figures is your thing need? Random. Okay. IGCSE requires 3. I'll just put 3. Yeah. 81.7 liters. Oh, okay, I'm correct. So using this, you have to either Ralph, you can use calculator, right? Can you bring the back of your calculator there? All right. Can we switch to WhatsApp for a sec? I want to call with screen with screen so I can show you. I'm not sure. You probably know this, but I'll just need to make sure. For a second, let me do that. We need it for. It's fine. It's fine. It doesn't matter. I just want to make sure you know how to use the constant in the calculator. So just memorize this formula, okay? PV equals NRV. Yeah, yeah, okay. So we want to find the volume, right? That's what we need, the volume of carbon. So we can rearrange this to V equals nRT over P. N is the number of moles. So we already find it just now. That's the whole reason for calculation. 0.17 multiplied by R, which is in your calculator, multiplied by temperature, which is given here, 310, divided by 100. It's the constant. It's it's just the ideal gas law constant. It's a gas. We just use E already there. That's E for electrons. So you put 3.17 times R using the method I show you times 3 divided by 100, and you get the answer. Yeah, you don't have to memorize the formulas or whatever, like constants, because wait, let me check the constant for the uh what is called the water. What is it? C? Wait, let me check. Water latent specific heat. 4.18. It's C. Is there a C here? C0. No, that's speed of light. uh, C1 29. 3.7. That's not it. 30. No. Yeah, KCO calculator. Does it exist? Yeah, I don't think it exists. I don't see a C. I don't see. Yeah, that's the only thing you have to memorize, I guess. Yeah, C0 is speed of light. C1 and C2 is not it. Yeah, whatever. Let's just ignore that. Oh, okay, that's fine then. Yeah, I know it's usually there. Like for the electron or like the size, I still use the calculator one because it's easier. Even yeah, and A is there 24. I'm looking at the calculator. The calculator has Avogadros. Yeah. So sometimes it gives you like more advanced material that you don't need. That's what they did for A level. Like during math, they give us like linear algebra stuff. Like what the fuck. All right. That's it. We got the answer. Just using that formula. Okay. Oh, sorry. Okay, testing. All right, just now, right? PV equal, yeah, with mole is this, N is mole. So volume, nRT over pressure over P. So this is P, this is N. I should probably not put, it looks like a divide. This is N, R is from calculator. Yeah, obviously. Kilopascals, pressure is here. 100. Just put this calculator, you got the answer. Kilopascals, yeah. The formula, you need to put kilopascals, not pascals. Yeah, has to be kilopascals. It doesn't matter. It gives you in liters. This is not in cancellation. This is like theory. Yeah. If it's not kilopascals, just turn it to kilopascals. It's just divided by 1,000. If it's pascals, it's 1,000. What, sorry? 1,000. Yeah, it's kilo means, right? You know how to turn bytes into kilobytes? You know how to turn kilograms to grams? It's the same thing. Yeah, it has to be Kelvin. Yeah, it's probably given to you the unit you need because I mean, unless you're evil. Yeah, so sometimes you use Celsius. You have to change them. But if it's different, you can just use the Celsius. Doesn't matter. Right, Ralph? Are you there?
Appetizer.
Oh my God! What? What? You learned this? So, a mass spectroscopy? Mass spectroscopy? Jesus Christ! Okay, I don't remember this. What the fuck? Why do you learn this? I do, but it's hard. What the fuck? Wasn't here. Huh? God damn, bro. Okay. I don't remember this. I had a chart before, but I don't have a chart anymore. We have the chart. We were skipping this. Oh wait, question what? 29, 28. Yeah, yeah. I'm checking. Yes. Holy shit! You learned this. Oh my fuck. Oh my fuck. My brain's also. I may or may not teach. I don't think I'm gonna teach this. This is depressing. Oh my god. You just skip this question. Yeah, it is worth a lot. In my final exam, it's worth like 30%. Holy shit, though. Oh my, this is really, this is really hard, Ralph. It's like solving a puzzle, but a really confusing one. I can try to teach you at least, but okay. This may take a long time. Oh god, why is this here? I can't escape from it, man. 20 and 3 marks. No, that's 28. 5 marks. I, if it's actually 5 marks out of 100, I think it's more worth it to learn something else. This is the hardest one. This is the hardest one. It's depressing. Either that or you're gonna get Anto to teach you because I'm not very proficient at this. But like, Anto. He probably has like so, I don't know, bro. Yeah, I'm skipping this. I'm skipping this. I'm not doing that. I thought I'd be free for NMR forever, but no. Of course, I find NMR again. Yeah, following graph shows the solubility. I find the relationship between the trend down in the oh, this is just explanation. Huh. Uh, the higher the molar mass, the less solubility in water. Why? I don't know. Explain the relationship between the trend shown in the graph and the relevant intermolecular forces. Higher molar mass, lower solubility in water. Soluble in water. I would say maybe, but my intuition is that usually to be solvable and what's it called to dissolve, it needs to be turned into ions. Maybe it's harder for bigger, but how? What does it have to do with intermolecular forces? It's like the strength between the attraction strength between the atoms, like the bond, like the bond. The bigger this is, the stronger it is. It's maybe it's because like yeah, what's up? The bigger the atom, there's higher, but intermolecular. Wait, let me think. What's her name? Okay, I think this is something to do with organic chemistry because of the alkene 1O. So I remember the longer the hydrocarbon chain, the harder it is to dissolve. So that probably has something to do with this. So the longer the hydrocarbon chains is, it is harder for water to dissolve it because I don't know. I don't know why. Well, I don't know why it's like that. Yeah. What do you think? It's not about density. It's not about that. It's about the chain length. I am pretty sure because the length of the chain. For example, we have a methanol. What? And we have like what like wait, it's the decanol. Is it decanol? Yeah, it is decanol. Okay, yeah. I was wondering if it's decanol or decanol, but decanol sounds retarded. So we have methanol. I guess it's anol, not null. Okay, and decanol. Methanol is much easier to dissolve in water compared to decanol because of the chain length. Methanol is literally just mass is one. It's like CHHH, right? For decanol, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is decanol. So it's about chain for sure. Oh, it's 5. Fuck yeah. So just ignore me. Also, this is not this. Yeah, get up. Oh my god, this guy genius. I don't understand this. Well, it's just kind of weird. Like, is this even viable? Because it's just like a single carbon. I don't have, Well, there's only 2 carbon, so like, yeah, I know that's just stupid. Whatever. Okay, yeah. This much harder to dissolve in water. I don't know why. I just know it is. That's retarded. We should check the question, Suki. As the molar mass increases, the chain length increases. As the chain length increases, solubility of alkan 1-ols in water decreases. Shorter chain alcohols dissolve in water due to formation of hydrogen bonds between the hydroxyl group of the alcohol and water molecules. However, as the chain length increases, the dispersion forces between the alkyl groups become more significant, which is crazy. Yeah, I think you should memorize this. What the fuck? I don't know what this means, Ralph. What the fuck? Why is the dispersion forces more significant? What does this have to do? What does this have to do with solubility? I think just like higher chain lengths equals to dispersion increase in this dispersion dispersion force, which is decreases solubility. I don't know what it's basically this is the whole summary, but I don't know what this middle part is. Yeah, it's quite complicated, I think. Sorry. Oh god, I don't know how to explain it properly. God, this gets into some. Oh, it's these. Oh god, oh my god. You learn this physics. We learn this in chemistry. Separation of opposite electrical charges. It's just a separation between the. No, it's about charge. Magnetized charge was study with Miku. What the fuck? It's just low fi. Insane. I didn't really know Miku songs. I don't get Vocaloids. Uh, you will get 4 marks, 4 out of 6. This is I think yeah. No, like, oh, this is how it works. Oh yeah, you'll get 2. You'll get 2. I thought it's like cumulative. Sorry, I didn't think it's cumulative. I think it's a. So, yeah. Water sample contains at least one of the following anions at concentrations of 1 mole a liter minus 1. Bromide and carbonati, and bromide, the bromide, bromide. Outline a sequence of tasks that will perform in school library. Oh my fucking god! I don't remember the tests. Ralph, fire test for what? Ralph, how do you burn carbonate? Ralph, you're high. You can't burn carbonate. What? No, I'm just like thinking like what the fuck? I mean, can you burn carbonate? Such a stupid question, bro. It's such a any organic matter within the carbonate. No, carbonate is an ion in the thing. That's not how that works, no. Aqueous nitric acid bubbles indicate carbonate present. Acid removes carbonate. You need to remember, these are memorization. I don't remember this. At silver nitrate solution, creamy participate. Yeah, these are the tests in unit 8 of you. Yours. Apply chemical item. Yeah, I don't know. This is all memorization. The spectroscopy is memorization plus logical thinking. It's worse. Yeah, I don't fucking remember. No, it's not. Oh yeah, we missed spectroscopy. I'm not explaining. Let me check. Could be titration, but I don't know. I don't think it's titration. These have no calculation. It's just explanation. I'm not good at that. Oh, sorry. The thing you sent me. Where? This, yeah, it's this. What? Oh, this chemistry notes off. What? It's the same thing. What's the difference between this and this? But yeah, spectroscopy is okay in organic chemistry, not them. Mathematical and metric. Oh, I mean, there's also that. I guess called it, but it's more like it's a chemical test. I don't know what unit it is. Oh, whatever, bro. I don't know, bro. I exactly cannot teach you that. Okay, I'm getting depression by just looking at this question. Copper ions form a complex with lactic acid as shown in the equation. What? I don't know. This looks like what's it called, the transition metals. I don't pay attention to transition metals on unit. I just YOLO that one. The complex can be detected by measuring absorbance. Wait, no, I was sick. That's why I didn't get. By measuring it, absorbance at millimeters. Oh my fuck! Oh my fuck! I cannot help you with this. What is this? It's just a graph. The complex can be. Do you just graph this in? Yeah, you just graph that in, I guess. Huh. Okay. I don't know, bro. It's probably that also depressing. I cannot. Okay. Hydration. Okay. Hydration not bad. Alright. The amount of ion content of mixtures can be determined by boiling the mixture. This shit's killing me. The ammonium ion content of mixtures can be determined by boiling the mixture. How do you find out that? This converts the ammonium gas into gaseous ammonia, which is removed from the system. The excess sodium hydroxide that can be titrated with acid solution of known concentration. A fertilizer containing ammonium ion. Okay, that some fertilizer, 50 milliliters of this much. From this, I can tell I can get the of sodium hydroxide solution boiled. Oh my god! Never mind. I take my words back. Mass of ammonium. Okay. I have to read this slowly. Fertilizer with sodium hydroxide solution. And then, after ammonia is removed, transferred into a volumetric flask and made up to the mark with the ionized water. Aliquots, I don't know what the fuck that is. It doesn't matter. I think of the solution or titration. Okay, I think first of all, find the average of this. I think find the average of that. That is this cancels out with wait. I mean 95, 90. No. Let's. What, sorry? This cancels out this. It's 22. The first one is the quick test. The first one isn't count. Remember when you do titration, the first one is just a rough estimate. So like you what's it called? You wanna try to get like the average, I guess. I don't know, because like it's so far from the others. I just think it's an outlier. I'm not sure if that matters. Not this. I need the yeah. Okay, it's not included. It's 22. It's 22 milliliters, which is 0.022 liters. So we have titration of hydrochloric acid. We have liters, we can find moles. We're using unit cancellation. What do we do? Multiply or divide? Correct. We find the volume of HCl. So we find any relevant information of the HCl, hydrochloric acid, which is the concentration. No, because it has nothing to do with the HCl. Yeah, I do solve calculations with logic. That's what I do. That's what? No, you will understand it by doing this. I think you'll understand it less if you memorize the formula. That's just my opinion. But like 2.42 times 10 to the power negative 3 moles. All right, we got the moles of hydrochloric acid, meaning we can do. I wanna say mole. I wanna say what's it called? Wait, no, it's titration. So we can just yeah. What, sorry? Mass, just normal mass, I think. What was the question? I don't remember. Ralph, can you check your question in the in your screen? Let's see what connects to the hydrochloric acid. 20 milliliters of the solution. What solution? Of the resulting solution. Oh, of the ionized water. I need volumetric fast. Let me think. Sample fertilizer or treated at sodium hydroxide. Oh, okay. So we're trying to see how much sodium hydroxide has been reacted with the fertilizer. So you wanna neutralize all of the sodium hydroxide. So we get, this is the moles of HCl, right? We also get the same amount of moles of NaOH. Sodium hydroxide, yeah. Because okay, the purpose of this experiment is you mix fertilizer with sodium hydroxide, right? And then you titrate it with hydrochloric acid to see how much sodium hydroxide is left in the solution. All right, get it? All right. What, sorry? Yeah, how much is reacted? And HCl and NaOH is the same mole ratio. So you just, yeah, they combine to water and salt. What, sorry? No. Ralph, mole ratio, Ralph. 1 to 1 to 1 to 1. So if you have this, if you have this, it's the same ratio. Yeah, okay. So this is in 20 milliliters, but the total is 250. So we have to multiply it. So 250 milliliters divided by 20 milliliters multiplied by this. Yeah, get it? That's right. Because let's say we have let's say 10 liters of water, right? Are you? No. Listen to me first. We have 10 liters of water. We take 1 liter of water, and we realize that each of them has 10 Orbeez. So 10 liters of water has 100 Orbeez, correct? The same thing with this. It's just 20 milliliters contain this much, so 250 should contain more. So we divide this by this, yeah. Yeah, that's like, I don't think it matters at all. It it just some fancy word that I've never heard of. Actually, I think he told me once. So it's 0.03025. This is moles of NaOH. All right. Yeah, this one is kind of okay. All right, we have, this is moles of sodium hydroxide. We find that there is sodium hydroxide information here of the concentration. So we can cancel out the moles and get the liters. Do we divide or multiply? We use this and this information to get the liters of the sodium hydroxide, because we want to find the amount. Yeah, moles per liter. Mole from this and moles per liter. What do we do with this? We multiply or divide. If we times, it will be mole to the power of 2 over liters. Is that what we want? Yeah, it's over. Yeah, the liters is negative. We want to find the liters. So, is it mole divided by moles per liter, or is it moles per liter divided by mole? Nope, it's this way. Because, again, we want, this is moles, mole, liter, minus 1. If we divide this by this, we get liter minus 1, not liters. So we put this on the bottom. Yeah. All right then. This is really long. Okay. 0.03025 moles. Too sick fix. You know what? I'm 1.124 mole liter minus 1. Alright, 0.0303 divided by 1.124. 0.2. Okay, that's a bit small. Is there something wrong with this? Oh, I was wrong. There's something wrong with me. My bad. In the sentence, it says, yeah, that's it. That's why you read the question properly. This is the property of this because English. So you divide this by this, not by that, and you find a difference between it later. Let's do that first. 50 milliliters. Want to find the mole? We want to find the moles. Yes, we have to turn this liters. 0.05 liters. Okay, multiply or divide to find moles. Zero point zero five time liters times 1.124 mole a liter. Boom, boom. 1.124 times 0.05. 0.05 moles. We find we minus this by this because it's titration. You're right, but we can find the mass with moles because we know the formula, NH4. N is how much is N? I don't remember. 16. H is 1. 16. The what's it called? The what's the periodic table? Periodic table. The molecular mass. Yeah. Atomic mass. How much is nitrogen? 14. 14, I think, right? What? Is it not 14? I'm gonna Google it. Wait. Let me take my phone. And I can't quit of this. Okay. Hydrogen is 1. I don't have to tell it. Yeah. It's around 10. It's around 10 to 15. I don't remember. Like the number. Try to find a number 10 to 15. Nitrogen is like the really top. It's second row. 14.1. So we have 1 nitrogen, 4 hydrogen. So it's 18.1 mole per gram. Mole gram minus 1, I think. Right? Oh no, it's gram mole minus 1. Yeah, atomic mass. Yeah. So we are almost done. We minus this by this to find the amount reacted with the fertilizer. This question is super gay. I mean, minus 0.03. I don't know. Well, whatever. We're almost done. Doesn't matter. 0.0252 2559 moles. Right? We have this, and we have this. We multiply or divide to find the grams. Multiply. Okay. Like 0.0.02595, not trying to units. We already know she moved by. 18.1. 0.469. I can't write it there. All right, let's check. Hopefully we're correct. Yes, close enough. 0.469. Yeah, got it. That was depressing. That was so depressing. Holy shit. Yeah, that bro, typing 33. Oh god. Wait, it's easy. Oh, it's enthalpy. Okay, explain what is happening. Oh, wait, I should probably. Yeah, and a container, volleyball, move piston. I just like calculation. Calculation is my thing. Direction between these two as follows: A to B to B to AB. It's like water, I guess. This is amount mole time minutes. So at between 6 to 8, nothing happens. So it is in equilibrium. Yeah, it is in equilibrium. Right? Yeah. Okay. Yeah. Yeah. Okay. Okay. Yeah. Okay. Free 2 points off. Wait. Yeah. This is worth 5 points. This is worth 2 points. Um, explain two different factors that could result in disappearance at 8 minutes. So the A increases, B increases, AB decreases. This is so of this is 3 to 2. So what? Sorry. Yeah, this is the pressure. This but is it increasing or decreasing? So yeah, this A and B is increasing. So this means that because it's 3, the space that occupies increased. That's why it turns here. So the pressure decreases. The piston moves up. Let me check. And in 8 minutes, there's no instantaneous chance, but air produced. This could be temperature. I forgot temperature. Increase in volume. I'm correct with one of them. I forget about temperature because I'm high. The increase. Oh yeah, the enthalpy. I forgot. I completely like missed it. Forgot this information. This is minus is endothermic. Endothermic. Exhaust out. Yeah. So if to make this, it's endothermic. To make it back, it's exothermic. So to increase it, to increase the products, you need to increase the temperature, which is it decreases. The increase in temperature. No, increase in temperature. Yeah, I'm correct. I'm correct. So so this is the forward one. This is endo. This is exo. We want an increase in AB because this increases. So we know that temperature increases. Yeah, it was easy. They get 6 points. No. So, uh, which one increases? The products or reactants? The reactants increases. This reactant off. This is products. Yeah, like 1 plus 2 is 3. This is 3. This is 2. So an increase in this means that there has to be more space because if not, that can't. So in more space means the piston moves up, meaning pressure goes down, which makes which makes less of this but more of this. Yep, that's easy. That's free 6 points compared to this. It's depressing. If it's 10 points, I understand. 5 points, bro. I don't know. What do this? That's probably my. I'll explain one more question. I'm asleep. 7. When 125 milliliters of magnesium nitrate solution is mixed with 175 moles. Okay. KSP. I don't remember the formula for KSP. What is KSP? If you can. Equilibrium constant for solid substances. Is okay, so it's the solutions only. Yeah. Okay. 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 It's like KC, but it's just the top part. What? Oh, that thing. Yeah. Yeah. Okay. I use a different. Yeah. A magnesium nitrate solution. Is mixed with. I don't know. I don't. Honestly, I don't know I forgot the definition. It's been a long time. For solid substances, I don't know what this means. What? It may be 3 or 2 or 1. I don't know yet. I'm gonna go in the morning for sure. But after lunch, I'm probably gonna go back if I'm allowed to. I'm allowed to, yeah. Spectroscopy. It's NMR. Yeah, NMR. It's hard and it has a lot of points. Now there are so many steps to it. You first, you first have to find the what's it called? You can find the what's it called? Like what kind of molecule it is by looking at this. You have to you have to look at this point, like, and there's 2 peaks here. So we did this on 130 ish. This is on this and this. Then you find triplet, multiplet, triplet, quad. It is. It was easy not at teaching, but I've forgotten, and I am not relearning that. I get a PTSD when I see the spot pen region. Holy fuck! You don't really read the graph. I mean, I guess you read the graph, but this is what matters. This is what matters. The data, you can ignore this completely. They give you the data, which is quite actually handy. But it doesn't matter. I'm not teaching it. That's something I want. You ask us about. I'm gonna teach 34. Hopefully, I still remember KSP. Then I'm gonna go. Okay, I'm gonna go now. Goodbye then. All right.